Hi there everybody, my name's Jamie and I'm a PhD student from Cardiff University. I study chemistry, which is the science of everything around us, and today the videos that you're about to see are going to teach you about acids and bases. So how this is going to work, we're going to have red cabbage, which is just ordinary red cabbage that you might find in your coleslaw or something like that. But what happens is, if you boil it up, it contains a compound which will dissolve into water, and this compound will change colour depending on if it is next to an acid or a base. Now you might be wondering what a base actually is. A base is actually the opposite of an acid, and scientists such as me and my friends, who you'll see in a moment, use something called the pH scale to determine if something is an acid or a base. Now, the red cabbage works as a sort of pH scale in itself because ordinarily it is purple, but if it is next to an acid, then it will show a different colour, so it will show red, which is a pH of between 1 and 6. However, if it's near something that is an alkali or basic, which is another word for alkali, it will change colour to blue, and then it will have a pH of between 8 and 14. If it's neither of these, if it stays exactly the same colour, as in it stays purple, then it has a pH of 7. The indicator won't indicate anything and it will stay exactly the same, so in this case it will stay purple. And for when that happens, there's a special word called neutral. So I've rang up all of my friends who are all in their own homes, and hopefully we will be able to see some interesting chemistry in a moment. So here I am in the kitchen. All I'm doing in this section is just cutting up some cabbage so that when I get to boiling it in a moment, we get more of the colour changing chemical to dissolve inside the water. Here we've got the red cabbage boiling away nicely inside a pan. What is happening here is that the chemical inside the red cabbage, anthocyanin, is dissolving from the red cabbage into the water. And it's this anthocyanin that will help us decide if something is an acid or an alkali. And just to show you how easy this is to do at home, all we're doing is pouring off the hot cabbage water into a jug, and it's this hot cabbage water that we'll be using as an indicator for the experiments in a moment. So in this experiment I'm going to be using some baking powder which I've had left over from making some cakes in my spare time. I'm about to add some of the purple indicator. Now, you won't be able to see exactly what colour it is straight away because it needs a little bit of time to mix properly as it's a solid. Baking powder is mostly made out of a chemical called sodium hydrogen carbonate, and it's used in baking because when it's heated it releases some carbon dioxide. As you can see here, it's rising ever so slightly, and that's because the indicator that I'm using was quite warm and it's releasing carbon dioxide. So I'm just giving it a bit of a shake here, and hopefully you can see that it's gone from quite purple to a light blue colour, and this means that the baking powder that we're using is a base. In this experiment I'll be using bicarbonate of soda, which is another thing that you can use when you're making cakes or bread or any other kind of bakery. Bicarbonate of soda is another name for sodium bicarbonate, and the way it works when you're baking is that it will release carbon dioxide and that will make things rise. So here I'm going to add some of the indicator now, and once I've added enough of it you should be able to see that the indicator has changed from purple into blue. Now it's a really strong blue because bicarbonate of soda is quite a strong base, and when I shake it here you should be able to see a nice blue colour. So here I've just opened a can of Coke and I'm going to pour a little bit inside the mini beaker and I'll have the rest later. I'm going to have to add quite a lot of the indicator in this experiment because I'm adding a really dark purple indicator to a dark coloured Coke liquid, so we'll have to add quite a lot of the indicator so that we can see any changes within. And I think this is probably one of my favourite reactions that I'm going to show you today because the result is quite surprising. I'm going to shake the beaker around in a moment and you should be able to see what colour it goes. So hopefully you can see that it's gone a little bit red here. It's quite a dark red, so this means that Coke is really acidic. The reason it's acidic is because it contains something called phosphoric acid, and that helps give Coke its tangy taste. In this experiment I'll be using lemon juice, so I'm just going to add a little bit of the lemon juice inside the mini beaker. Lemons are a type of fruit which are classified as citric fruits, and you might have heard of an acid called citric acid, which is inside lots of things like oranges and lemons and limes. So because of that, you might be able to guess what colour the indicator is going to go now. So yeah, as you can see, it's gone pink immediately, and this is because of the high amount of citric acid which is inside the lemon juice. So I'm just going to shake it around in a moment just to show you how acidic lemon juice is. And this citric acid helps give lemon juice its taste. It's quite tangy and also quite nice on your pancakes. In this experiment we'll be using milk for the reaction. When we're using milk, it can be quite difficult to see a colour change with the indicator because milk is such an intense white colour. So when I add in the indicator over here, you might think that it's going maybe a little bit blue, a little bit purple, but in reality this just means that the indicator isn't really changing colour. This means that milk isn't really an acid or an alkali, it's more neutral. In reality, milk is ever so slightly acidic because it contains small amounts of something called lactic acid, but it's about a pH of 6.7, so for the purpose of this experiment we can call it neutral. In this experiment we'll be using soap. So just to show how everything around us is to do with chemistry and how everything has an acidity or a basicity, we're going to use some hand wash. So I've added some indicator here, and in a second I'll shake it a little bit so you can see the colour change, because at the moment the indicator isn't really indicating anything. So I'm about to shake the mini beaker now, and hopefully you can see that it's gone from purple to a really mild pink, which means that this hand soap is ever so slightly acidic. In this experiment I'll be using some washing up liquid that we use to wash up our dishes. So I've added quite a lot of this now. It can be quite difficult to see what colour the indicator is going again because the washing up liquid that I use at home is so green, but hopefully you'll be able to see when I shake it in a moment. So the washing up liquid is quite dense, which means the indicator is floating on the top, which means I'm going to need to shake it to show if there's any colour. So I'm just going to shake it here now. As you can see, the indicator hasn't changed colour, which means that this washing up liquid isn't an acid and it isn't a base, which means it is neutral. In the beaker here, I've just got some water that I've got out of the tap. As I add the indicator, you can see that the indicator just mixes with the water and doesn't really do much. Here, this means that the indicator isn't indicating anything, which means water isn't an acid or a base. It's actually something that we call neutral, which means it's neither an acid or a base. Okay, so I hope you all enjoyed that. Huge thanks to all of my friends and colleagues that did some science at home so we could share it with you today. I hope that it might have inspired you to try this experiment at home because all you need is red cabbage, maybe some lemon juice or some bicarbonate of soda or maybe even some vinegar. I hope that you might be inspired to do it yourself, and hopefully when coronavirus is all passed over we'll be able to come into a school and do the experiment with you. So thanks very much for listening, guys.